equations with square roots. So this is the second method that we're going to cover of solving quadratic equations. And this one might be the most intuitive, right? Because if you think about like a quadratic having x squared, the inverse operation of that is square rooting. The problem, though, comes when we have x squared, or like an ax squared plus bx plus the c, thinking about the standard form. There's no way to combine these two because they're unlike terms. And so one has a square and one doesn't. And so because of that, there's no way to isolate the x's using our inverse operations we've talked about before, like adding, subtracting, multiplying, dividing. And so what we're going to do is talk about when we are able to use square roots. And then the rest of our methods will be about other ways to combat solving, since we have that pesky quadratic term, linear term thing going on. So we can still solve with square roots when b is equal to 0. So I guess I shouldn't have erased that standard form. Okay, so remember this is the standard form. So in that middle term, if b is 0, that means that we just have something that looks like ax squared plus c. Totally legal, right, to solve that, because we can isolate the squared term that way. Or if you have it in vertex form, so something like in one quantity squared. Okie dokie. So, let's talk about our steps for solving. Oh no, it says by graphing, and that should say square roots. This is literally the second time that I've had one of those oopsies, but if you buy the notes, it's going to be a-okay. I'll fix it before then. So solving with square roots. Yikes, did I mess up any of the other ones? Sorry, I'm just looking at my notes now because I'm like doubting myself. Yeah, alright, I think I'm good. Okie dokie. So we are going to use our good friends inverse operations to isolate that squared term. Then we're going to square root both sides of the equation to cancel out that squaring. And we're not going to forget plus or minus. Since we're taking the square root of both sides of the equation, we need to have plus or minus. And then, if necessary, we're going to keep using inverse operations to isolate x, right? Especially like if we are dealing with something where it had been in that vertex form, we might have to still do a little bit more work to get x by itself. All right, so let's see what's going on here. All right, so I have x squared plus 7 equals 71. So again, I'm trying to isolate this x squared. So I'm going to start by subtracting 7 from both sides, and I'll get x squared is equal to 64. Now I'm going to, so if we're thinking about our steps, right, that's the first one, isolate the x squared term. Now I'm going to square root both sides of the equation, right? Because if I do it to one side, I have to do it to the other as well. So I'm going to end up with x over here because the squaring and square rooting cancel. They're inverse operations. Then over here, I'm going to have plus or minus 8 because I took the square root of 64. Now, of course, right, I'm not neglecting that plus or minus because it could have been positive 8, but it also could have been negative 8. And there we have it. We solved our first quadratic with square roots. Nice job. Okie dokie. Let's check out this one. All right, notice that we're going to do a teensy bit more work because our x squared here has that negative in front of it that we're going to have to get rid of as well. So I'm going to start by subtracting 4 from both sides. We'll get negative x squared is equal to negative 24. Now I'm going to multiply or divide, either way works, both sides by negative 1. And so I'll end up with positive x squared is equal to positive 24. All right, and so all of that we're doing right there was to isolate, again, that squared term, that x squared. Now we're going to square root both sides. All right, so now I've got x is equal to, I'm not going to forget plus or minus, the square root of 24. Now remember, 24 is not a perfect square, but it does have a perfect square factor. Right? I could think about breaking this up as 4 times 6, and I can take the square root of 4. So this will be plus or minus 2 radical 6. Right, so sometimes we do have a little bit of simplifying that has to take place. On to the back page. All right. So here, our squared term is this vertex form here, but it's a whole quantity squared, not just x being squared. And so I could divide both sides by 1/2, but I think it's even faster if I just multiply by 2, because that's what we end up doing anyways when you are dividing by a fraction, multiplying by the reciprocal. So I'm going to end up with x plus 2, quantity squared, is equal to 36. And now I'm going to square root both sides. And I'll have x plus 2, well, I guess I don't need the parentheses anymore, is equal to plus or minus, can't forget about that, 6. All right, now this is our first one where x still isn't solved for, so I'm going to have to subtract 2 from both sides. So we have x is equal to negative 2 plus or minus 6. And we can carry out that plus or minus. What I mean is I can say, well, okay, what is negative 2 minus 6? That's negative 4. And what's negative 2 plus 6? Or negative 8. And that's positive 4. Right, so if you only have numbers, there's no variables or nothing like irrational, like a square root in there, you can totally just add and subtract those numbers. That is where my students usually get stuck. Alrighty, let's look at this next one. Alright, we can start by dividing both sides by 3. So we'll have x minus 4, quantity squared is equal to 4. We're going to square root both sides, so we'll get x minus 4 is equal to plus or minus 2. I'll add a 4 to both sides, and I'll end up with x is equal to 4 plus or minus 2. And again, we can carry out that addition and subtraction. So 4 minus 2 is 2, 4 plus 2 is 6. There you go. All right, go ahead and try C and D on your own. So pause the video, go ahead and try C and D, and then go ahead and come back. Welcome back. All right, we are going to subtract 3 to get going here. So I've got x squared over 2 is equal to 14. I'm going to multiply by 2 on both sides. I'll get x squared is equal to 28. Now I can square root both sides, and I'll end up with x is equal to, not forgetting my plus or minus, the square root of 28. Now 28, not a perfect square, but it has a perfect square factor in 4, right? This is 4 times 7, 28. And so I can say that x is equal to plus or minus 2 radical 7. Over here, we're going to add 17 to both sides, and we'll end up with 5 times x minus 3, quantity squared, is equal to 35. And divide both sides by 5, and we'll end up with x minus 3, quantity squared, is equal to 7. Square root both sides, and we'll have x minus 3 is equal to plus or minus radical 7. And then we'll have to add 3 to both sides to get x all isolated. Now this, we cannot carry out that addition or subtraction because 7 is stuck in that radical jail there. Right, he's irrational, and we can't add. We're going to leave it in simplest radical form, like this. All right, y'all, we've made it to the very last question. Okie dokie. So we're going to subtract 8 from both sides. Following good reverse order of operations, taking care of that first before that multiplying by 9. So this is going to be equal to 432. Divide both sides by 9, and we're going to get 2x minus 3 quantity squared is equal to 48. We're going to square root both sides, and we'll get 2x minus 3 is equal to plus or minus radical 48. You could choose to simplify that now, or you could choose to simplify that later, kind of whatever floats your boat. I'll just simplify it now. So this is 16 times 3. So I'll have 2x minus 3 is equal to plus or minus 4, because I took the square root of 16, radical 3. I'm going to have to add 3 to both sides. So I'm starting to run out of space, so I'm going to move up here. So I'll have 2x is equal to 3 plus or minus 4 radical 3. Now I'll divide both sides by 2. I'll have x is equal to 3 halves plus or minus 2 radical 3, because I divided both of the terms in the numerator by 2. So there you have it, folks. We just solved a bunch of quadratic equations with square roots. All right, I'll see you guys later. Bye.